Hello, this is an application of the use of Lorentz equation for the case of electrons and protons. We have seen that whenever a charge sees a magnetic field, it starts going in circles, and it has primarily two properties. One is the cyclotron frequency, which tells us how frequently it goes around in the circle, and of course, once it's a circle, what's the radius of the circle. And here we have a proton and electron. So let's start with part A. In part A, let's have a diagram to begin with. So the magnetic field is going into the board, and our X and Y direction are the typical X and Y. And that's your K hat. Right. So magnetic field is going into the board because it's minus 2. The velocity of both the proton and the electron is this direction v. And if it's a positive charge, it will actually go to the top. And if it's a negative charge, it will actually go down. Right? And the radius of the two will be different, which we will calculate as we proceed into the problem. What is the force? Force is equal to Q. Magnitude of the force is Q times V times B, and the angle between V and B, which is 90 degrees, so sine of 90 is 1. This is equal to 1.6 into 10 raised to minus 19. It doesn't matter whether it's electron or proton, both have the same charge, times the velocity, which is 3.0 into 10 raised to 5 times 2.0, which comes out to be that's 9.6 into 10 raised to minus 14 newtons. That's the force experienced by both the electron and the proton. What are the directions when it comes to the proton? It is positive J, and if it is the electron, it is negative J. It's upward and downward direction. This is right at the instant it begins. Of course, it is radially centered. The force is radially inward. That's the way to say it. This is only the initial directions of the forces. So we should say this is radially inward as the charge moves on. What is the accelerations experiences by the two charges? Let's begin with a proton. The acceleration is force over the mass, so that's 9.6 into 10 raised to minus 14 divided by the mass of the proton, which is 1.7 into 10 raised to minus 27 kgs. So that comes out to be 9.6 divided by 1.7. So that's 5.7 into 10 raised to 13 meters second square. Similarly, for electron, this information comes out to be the acceleration is the force is the same, and we have divided out by the appropriate mass of the electron. Mass of the electron is 9.1 into 10 raised to minus 31 kg. And doing this gives us 9.6 divided by 1 That's 1.1 into 10 raised to 17 meters per second square. So the electron experiences a significantly larger acceleration than a proton. And of course, these accelerations are humongous when compared to the daily accelerations we experience on an interstate. So that's part C. Let's go to part D. Part D, basically, speed is of course given to us. It is asking us what the path of these particles are, and they are circular paths. So speed is of course 3 into 10 raised to 5 meters per second, and it's a circular path. Part E, determine the cyclotron frequency of the proton and the electron. Let's start with the proton. So proton cyclotron frequency is Q B over M. So it's 1.6 into 10 raised to minus 19 times the magnetic field, which is 2, divided by the mass of the proton, which is 1.7 into 10 raised to minus 27 kgs. That gives us in radians per second. That's 1.9 into 10 raised to 8 radians per second. So it's uh, going around very fast. What about electrons? Same idea, but now we use a different mass. So it is 1.6 into 10 raised to minus 19 times 2.0 divided by this time the mass of the electron, which is 9.1 into 10 raised to minus 31. Now that's 10 raised to 11, 10 raised to 12, and that's 3.5 into 10 raised to 11 radians per second. So let me check this out. Yeah. Okay. So again, the electron moves much faster, more frequently goes around the circular part. Finally, what is the determine the radius of the circle described by the two particles? Again, proton and electron have different masses, so the radius will be different. So radius of the proton is V over omega. So velocity was 3.0 into 10 raised to 5, and cyclotron frequency for proton is 1.9 10 raised to 8. So that's it's 1.6 into 10 raised to minus 3 meters. So it's about 1.6 millimeters. Really tightly held. Uh, what about the electron? This is V over omega, same velocity, but now a different cyclotron frequency, which is 3.5 into 10 raised to 11. That's 0.86. So that's 8.6 into, so that is a 10 raised to 6 upstairs. That's 10 raised to 5 meters. Okay. And in kilometers, this comes out to be about 860 kilometers, which is about 500 to 600 miles. So that's the difference between a proton and an electron. Clearly, a factor of 1,000 showing up. Let me stop the video at this stage.